Hello and welcome back. So in this video we will talk about the sum of the first n terms of an arithmetic progression. So the sum of n terms, the first n terms, the sum of the first n terms of an arithmetic progression. So basically in one of the parts that we discussed in this chapter, we talked about Shakira that puts basically 100 rupees into her daughter's money box when she was 1 year old, and then 150 on her second birthday, 200 on her third birthday, and so on and so forth. And in the previous parts, meaning that basically she started with 100 rupees, and then the next time she increased that amount by 50 rupees, and so basically in total she deposited 150 rupees into the money box after 1 year. Then again after 1 year increased this by 50, so she deposited 200, 250, and so on and so forth. So the questions that we were trying to answer before were, for example, along the lines of, for example, now on her, how much did she deposit on her, for example, 10th birthday? How much, for example, did she deposit? How much did she deposit on her, for example, on her 10th birthday, for example? On her 10th birthday. And so we answered this question by taking a look at the nth term of an arithmetic progression, because this is indeed an arithmetic progression. And so we said that in this arithmetic progression our first term was a, which is 100 here, and the common difference here is 50, and we derived the formula a of n is equal to a plus n minus 1 times d. And so we said that a of, for example, 10 would be equal to basically a, which is equal to 100, plus n minus 1, which is equal to 9 times 50 is equal to 450. So that's 100 plus 450, which is equal to 550. Which means that on her 10th birthday, if you keep writing this 250, 300, 350, 400, and 450, 500, and 550, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, exactly 550 rupees she deposited on her 10th birthday. Now, if I were trying to, instead of this question, if I were trying to answer the question, how much in total was deposited into the money box, during, for example, the first 10 birthdays, So So then to answer this question, I would just simply have to write, for example, I would have to take all of these amounts and add them together, meaning that I would have to write 100 plus 150 plus 200 plus 250 plus all the way up to 550, right? And that amount I would have to just simply add them together, which, as you can see, of course here there are 10 terms over here, so it's not impossible to add them. You can add them together. But suppose that there were, for example, 1,200,000 terms, for example, here. Then, of course, it wouldn't be possible for you to just sit down and add all of these numbers together. Which was, of course, the case when people didn't have formulas in mathematics. Of course, this is something simple. They must have derived such formulas early on, but there were formulas in mathematics that, for example, at the time of Ramanuja, 200 years ago, I suppose, 100 years ago, 120 years ago. Back at the time, there were many areas in mathematics that they had no formulas for, and so mathematicians, and of course there was no calculator back then. There was even no calculator back then. I have heard that there were people there was a job description called a calculator. Which is, of course, very interesting. There was a calculator back then was a person rather than a device that you use in order to punch in your numbers and then get some answer. There were these people who were very good at arithmetic, was their job. And so wherever it was necessary to add numbers together, a whole bunch of numbers together, these people were hired sitting in big halls and just adding numbers together or subtracting and dividing and so on, and multiplying and so on and so forth on just simply simply sheets of paper, and using a pen, for example, and a piece of paper. This kind of person was called back then a calculator. But of course there was no such machine as a calculator yet. I don't know when the first calculators arrived. The first ones were, of course, big mechanical machines that worked with gears and things like that. And then eventually computers came with vacuum tubes, and then programs were written for these computers, and so then the calculation was given to these machines, which, of course, as you know, they did consume a whole lot of power, because you had to run a whole bunch of vacuum tubes all at a time, because the machine had to run. But well, back then there were not even formulas to do things, and so mathematicians, they used to just sit and add things together if they had to. Now, when it comes to this problem, for example, 10 numbers over here is pretty easy. You can just simply add them together and get the sum. This is the sum of the first 10 terms of this arithmetic progression. But if you were to add, for example, let's say the first 1,200,000 terms of this arithmetic progression, it would take you probably a week or so in order to do the calculation, even on a calculator, because it's not easy to enter numbers into a machine. And so now And so it seems that basically there was a mathematician called Gauss. There was a mathematician called Gauss to whom a problem was given when he was 10 years old. It seems that we have read about him in chapter 1 of the same book. And he was 10 years old. He was asked to find the sum of the positive integers from 1 to 100. He was asked to calculate the sum of the integers from 1 to 100. And he immediately replied 50-50. 50-50, right? This is the sum of the integers, sum of the positive integers, sum of the positive integers from 1 to 100. From 1 to 100, and he immediately replied 50-50. So it seems that the way that he did that calculation was that if you call the sum s, you can write this calculation as 1 plus 2 plus 3 plus all the way up to basically 99 and 100, right? And then if you reverse the numbers, you can write the same sum as 100 plus 99 plus all the way up to basically 3 plus 2 plus 1. And it's interesting that and we saw the same thing basically, well, it was actually not the same thing, but if you add basically these two equations together, you'll get 2s is equal to 100 plus 1 is equal to 101, 2 plus 99 is equal to 101, 3 plus 98 is equal to 101, 101 plus all the way up to, for example, 3 plus 98 is equal to 101, 2 plus 99 is equal to 101, and 100 plus 1 is equal to 101. And of course, this is basically 100 times, or 100 terms, which means that 2s is equal to 100 times, which is the same thing as 100 times 101, which means that s is equal to basically 100 times 101 divided by 2, which is equal to 50 times 101. That's 5 times 101, which is equal to 505, and a 0 there, and you get 5050. So that's basically how he actually added those numbers together. And so we can use the same technique that, of course, nobody knows how he did it, but it's written in the text that that's how he did it. So I'm just going with the text really. Now we are going to use the same technique, and our knowledge of these basically arithmetic progressions, how the terms are put together and how the terms are constructed, in order to calculate the first n terms, the sum of the first n terms of an arithmetic progression. So basically what we can say is that if you have basically let's suppose that the following is the terms of an arithmetic progression. And the terms are basically a, this is the first term, then you have a plus d, which is the second term, a plus 2d, which is the third term, a plus 3d, which is the fourth term, and so on and so forth. And the nth term of this AP, the nth term of this AP is basically, as we know, is a of n. We calculated that to be a plus n minus 1 times d. So that is a plus n minus 1 times d. Now, let S basically denote the sum of the first n terms of this arithmetic progression. Excuse me. Okay, so now let S denote basically the sum of the first n terms of this arithmetic progression. So we have basically S is equal to a plus d, a plus d plus a plus 2d, plus all the way up to a plus n minus 1 times d. Right? And rewriting the terms in reverse order, in the reverse order, we have basically S is equal to a plus n minus 1 times d, plus all the way up to basically plus the term before this becomes basically plus a plus, for example, n minus 2 times d, and plus all the way up to basically a plus, for example, a plus d, for example, plus a plus d, for example, plus a, right? And therefore, and then adding, and then if you call this 1, for example, and if you call this 2, then you can basically add 1 and 2 together. So adding 1 and 2, we have basically S plus S is equal to 2S. So that's a plus basically a plus n minus 1 times d, which is equal to 2a plus n minus 1 times d. And then basically over here you have a plus d plus a plus n minus 2 times d, which would be a plus d plus a plus n minus 2 times d, which is equal to 2a plus d times 1 plus n minus 2, which is equal to 2a plus d times n minus 1. So that is 2a plus n minus 1 times d. The same thing again. So you have 2a plus n minus 1 times d and then you can add all of these together, meaning that, for example, you can write basically, for example, the term that comes here. The term that comes here is the term that comes before this would be basically a plus n minus 2 times d plus a plus d. So that would be a plus n minus 2 times d plus, for example, a plus d, which is equal to 2a plus d times 1 plus n minus 2, which is the same thing as 2a, that is n minus 2 plus 1, that's n minus 1 times d. So you can write all the way up to 2a plus n minus 1 times d, and the last term would be basically these two terms to get added together. So you would have a plus n minus 1 times d plus a, which is equal to 2a plus n minus 1 times d. 2a plus n minus 1 times d. And that, of course, as you know, is going to happen, or would happen, n times, because you have n terms over there, right? This is basically n terms, because we had because this was the nth term, so therefore basically that all of these would be n terms, and therefore you can say that basically you can say that this is equal to basically 2s is equal to n times, and all of these terms are identical, so you can write n times 2a plus n minus 1 times d, and therefore or divide by 2, you will get s is equal to n divided by 2 times 2a plus n minus 1 times d, which is very elegantly the sum of the first n terms of an arithmetic progression. So, and therefore you can say that so the sum of the first n terms of an arithmetic progression is given by s is equal to n divided by 2 times 2a plus n minus 1 times d. That is basically the formula that we were looking for. And we can also write this as the formula can also be written as s is equal to n divided by 2 times 2a, or 2a, instead of 2a you can write a. So you can write a plus n minus 1 times d. Now you know that a plus n minus 1 times a plus n minus 1, you know that a of n is equal to a plus n minus 1 times d. We have already derived this formula, and therefore you can write this as S is equal to n divided by 2 times a plus a of n, right? A plus a of n. Now if there are only n terms in an AP, then a of n is equal to L, meaning that if there are basically only n terms in an AP, a of n is equal to L. L is basically the last term. But as you saw before, a of n basically denotes the nth term. The nth term can be the term in the middle, it can be the term 3/4 of the way, 3/4 of the way towards the end. It could be any term basically, depending on n. A of n you can of course calculate based on this formula. So what now we are saying that if there are only n terms in an AP, then of course a of n, the nth term, is going to be the last term, which is L, right? L basically denotes the last term of an AP based on our notation. So, meaning the last term, right? The last term. And so, from 3, basically if I call this 3, so from 3 we have basically S is equal to n divided by 2 times a plus L. N divided by 2 times a plus L. And so this form of the result is useful when the first and the last term of an AP are given and the common difference is not given. So for example, suppose that the last term, you have the last term of an AP, you already have it. The first term, you already have it. The number of terms, you already have them. But the common difference is not given. That way you can calculate the sum of the terms of the AP. So now we can use these basically this formula, which is all of these formulas are actually the same formula. We can use them in order to answer the questions that we previously had, which is basically, now we return to the question that was posed to us in the beginning. The amount of money in rupees in the money box of Shakila's daughter on 1st, 2nd, 3rd, 4th birthday were 100, 150, 200, and 250 respectively. So the money box that we talked about before, Shakila basically started with 100 rupees, and then in the next year she deposited 150 rupees, the next year 200 rupees, the next year 250 rupees. This is the first year, and this is the 4th year, right? And this is the 4th year. And of course she kept doing the same thing over and over again. We don't know how long, but we know that the first 4 terms, let's imagine that the first 4 terms were these terms over here. Now, since this is an AP, your A is equal to 100 and your D is equal to 50, and therefore we can calculate the total money, for example, collected on her 21st birthday. That is the sum of the first 21 terms of this AP. So now if you were to, assuming that Shakila basically kept doing the same thing for at least 21 years, then what was the amount of money collected? The amount of money collected on her 21st birthday. On her 21st birthday. Now, the first birthday is the first term. The second birthday is the second term. The third birthday is the third term. And therefore, the 21st birthday would be the 21st term, right? So that means that you want to, so we want to basically, we want to calculate the sum of the first 21 terms of this AP. So we can do the same thing by writing the formula as S of n is equal to basically n divided by 2 times a plus, or 2a plus, basically 2a plus n minus 1 times d. Right? We can use this formula because we know what the first term was. We know the number of basically we know basically the number of terms over which it happened, and also basically we know the common difference, which means that I can write S of 21 is equal to 21 divided by 2 times basically 2a, which is 2 times 100, plus n minus 1, which is basically 20, times d, which is equal to 50, right? Which means that I can take a 2 out here. I can write this as 21 divided by 2 times basically 2 times 100 plus basically 10 times 50, and that would be basically 2 and 2 you can cancel out. 100 times 50 is equal to 500. That would be 600. 600 times 21 times 600, which is equal to 612, and that is the amount of money that was collected all the way up to the 21st birthday. 12,600. So that was the amount of money collected on her 21st birthday. And so instead of S, we can now we can use S of n, of course, as I have done here. So we also use S of n in place of S to denote the sum of the first n terms of the AP. So for example, S of 20 to denote the sum of the first 20 terms of an AP. So for example, if I write S of 20, this notation means the sum of the first 20 terms of an AP. Now this the formula that we have for the first n terms involves basically 4 quantities. So the formula is S of n. We have n divided by 2, 2a, n, and d. So you have n and a and d, right? Or basically S of n is also involved. So you have S of n, you have a, you have n, and you have d. You have 4 quantities are involved. S, A, D, and n. if we know any three of them, we can find the fourth. So in order to find any of these quantities, of course you need to know the other three ones, and then you can solve for the fourth one. Now this was basically all that you need to know about calculating the sum of the first n terms of an AP. So now we will do a couple of examples in order to use these formulas. And as a remark, we could say that basically the nth term of an AP is the difference of the sum to first n terms and the sum to the first n-1 terms of it. That is, A of n is equal to S of n minus S of n-1. And that is actually something interesting, meaning that the sum of the first, suppose that you have some AP, for example, A1, for example, A2, A3, and so on and so forth, all the way up to A of n. And suppose that you have A of, for example, A of n-1 here, and you have A of n here, right? Now what you can do, S of n would be basically for example, suppose that let's say that A of n denotes or S of n denotes basically the sum of all of these terms. Let's say that, for example, S of n-1 denotes the sum of all of these terms, right? That would be S of n-1. And so if I write S of n minus S of n-1, of course that gives me A of n, right? S of n minus S of n-1, that gives me A of n. So this is also something that you can use somewhere. Let's see how we can use it. Now let's consider some examples here. Let's see what we have. Okay, so now if you basically, as an example, we have example number 11, which is basically find the sum of the first 22 terms, which is basically S of 22 of the AP, which is 8, 3, -2, and so on and so forth, right? So here basically your A is equal to 8, your D is equal to -5, and so we said that basically S of n is equal to n divided by 2 times 2a plus n-1 times D, right? So now S of 22 is equal to n divided by 2, which is 22 divided by 2, times 2 times a, 2 times 8, plus n-1, which is 22 minus 1, times d, which is equal to -5. I can write this calculation as 11 times 16 plus 21 times -5. 21 times -5 is equal to 105, -105. So that's 11 times 16 minus 105. Now 105 minus 16 is equal to minus 6 is equal to 99. That's 89. That's negative 11 times -89. And 11 times -89 is equal to 89, 0, 89, and then you have 917, 979. So that's negative 979. That is S of 22. Negative 979. So what this means is that basically if you write the first 22 terms of this AP, which starts with an 8, and then 3, and then negative 2, and then negative 7, and then negative 12, and so on and so forth, go all the way up to 22 terms, and take each of those terms and add them together, meaning that you write 8 plus 3 plus negative 2 plus negative 7 plus negative 12, and so on and so forth, all the way up to A of 22. That should be equal to negative 979. And you're getting a negative number because, as you can see, only these two terms here are positive, the rest of the terms here are basically negative. Or as another example, example number 12, we have, if the sum of the first 14 terms of an AP is 1050 and its first term is 10, find the 20th term. So the sum of the first 14 terms is S of 14 is equal to 1050, and its first term is 10. So that means that A is equal to 10. Now you want to find the 20th term. A of 20 is equal to what? So you can use the same formula. S of n is equal to n divided by 2 times 2a plus n minus 1 times d. So S of n is equal to, you can write basically S of n, take it as S of 14. You can write it as 1050 is equal to, so n becomes 14. 14 divided by 2 times 2 times 10 plus n minus 1. N minus 1 becomes 14 minus 1. 14 minus 1 times d, which is equal to d. We don't have it. So 1050 is equal to 7 times 20 plus 14 minus 1 is equal to 13, so that's 13d, right? So 1050 is equal to 7 times 20 is equal to 140. 7 times 13 is equal to 70, and 21, 91d. That means that 91d is equal to 1050 minus 140, and 1050 minus 140 is equal to 0, 1, 910. So 91d is equal to 910, which means that d is equal to 910 divided by 91, which is equal to 10. D is equal to 10. So now you know that basically your A is equal to, 10, and your D is equal to 10, which means that A of 20 is basically, A of n is equal to basically A plus n minus 1 times D. So A of 20 would be equal to basically A, which is equal to 10 plus n minus 1, which is equal to 19 times D. D is equal to 10. So that's equal to 10 plus 190, which is equal to 200. A of 20 is equal to 200. That means that the 20th term is actually 200, right? So the next question that we have is example number 13. We have example number 13, which is which is example number 13, which is how many terms of the AP, of some AP must be taken so that their sum is 78. So you're asking how many terms should be taken so that their sum is 78, which means that S of what n is 78. And your AP is basically 24, is 21, 18, and so on and so forth. Right? So over here you can see that your A is equal to 24 and your D is equal to negative 3. Which means that S of n is equal to n divided by 2 times 2a plus n minus 1 times d. If I take S of n as 78, that's going to be n divided by 2 times 2a, 2 times 24 is equal to 48, n minus 1 times d, which is equal to negative 3. And therefore 78 is equal to n divided by 2 times 48 times 48 negative 3n plus 3. 78 is equal to n divided by 2 times 48, actually 51 I could say. 48 plus 3 is equal to 51 minus 3n, and then you can say that basically 78 is equal to 51n divided by 2 minus 3 times n squared divided by 2, and then multiplied by 2, you'll get 156 is equal to 51n minus 3n squared, which means that negative 3n squared plus 51n minus 156 is equal to 0, which means that basically 3 times n squared minus 5n plus 156 is equal to 0. And then you need to solve this equation in order to get to the values of n. So in order to solve this equation, you can I cannot divide by 3 here because there's a 5 here and it's not divisible by 3. I could basically let's see what happens if we prime factorize this number. 156 is the same thing as 2 times basically 75, 78, 75, 140, 150, 178, 2 times 35, 35, 39, that's 3 times 13, right? So that means that 156 is 2 raised to the power 2 times 3 times 13. So, and 3 is, well, 3 over here, right? So therefore, if I write 3 times 156, that's the same thing as 2 raised to the power 2 times 3 raised to the power 2 times 13. Now, I need to write this number in such a way that the sum of the two numbers, becomes negative 5. Which means that I can multiply basically this is 9 and this is 4, this is 36. So if I go 13 times 4 is equal to, for example, 13 times 4 is equal to 12, 1, 52, and 9. No, that doesn't work. If I go 13 times, for example, 2 is equal to 26, and then times 3 is equal to, if I go 13 times 2, 13 times 2 is equal to 26, right? And then 2 times 9 is equal to 18. and 18, 26, so 26, 18, that's 2 and 6 is equal to 8. No. If I go 13 times 3 is equal to 39, and 3 times 4 is equal to 12. Doesn't work. Okay, so let's do it in another way. I'm going to write 156 times 3 is basically this number, right? Which means that it's 2 times 2 times 3 times 3 times 13. Now you have to write this in such a way that you get two numbers that are 5 units apart. So 36 and 13, of course, is not that sort of thing. 39 and 12 is not, of course, that sort of thing. 26 and 18 is not that sort of thing. Now let me see if I write this as 156 . Okay, so let's use basically the quadratic equation. I'm not getting anywhere with this. So the quadratic equation is x is equal to I haven't used this in a long time. Negative plus or minus square root of a squared minus 4ac over 2a. That's negative b plus or minus the square root of a squared minus 4ac over 2a, right? So basically I can say that x is equal to negative b, which is equal to 5 plus or minus now the square root of a squared minus 4ac here would be equal to a squared is 9, the square root of 9 minus 4 times a is equal to 3 and c is equal to 156, which is equal to 12 times, that would be a negative number, negative, have we not made any mistakes here? 78 times 2 is equal to 140 plus 16, 156. 51n minus 3n squared. And then we can write negative 3n squared plus 50, that's 51, that's the mistake. Otherwise, it shouldn't be that hard. Okay, so that's negative 3n squared plus 51n minus 156 is equal to 0. That means that 3n squared negative 51n plus 156 is equal to 0. And now you have basically 3, so we said that basically 156 is equal to 3 times, is equal to 4 times 3 times 13. 4 times 3 times 13, if I'm not mistaken, what is 12 times 13? Is equal to 156, right? So that's basically 3. That is basically 3 times 4. 3 times 2 squared times 13, right? And then 156 is the same thing as, and 156 times 3 would be equal to 3 squared times 2 squared times 13. And we have to put these numbers together in such a way that the difference becomes 51. So 13 times, for example, 13 times, for example, 9 is equal to 13 times 9 is equal to, that's too large a number, 90 and 27, that would be 117. That's a 4, so that doesn't work. 13 times 4 is equal to 40, and 12, that's 52. That's 52. And that is a 9. And that is a 9. So here the difference is about 40. No, that doesn't work. So I'm going to go with each of these numbers then. Basically, for example, 13 times 2 is equal to 26. And so then you have 2 times 18. And 26 and 18. So this is 13 times 2. And this is 13 times 2, and this is 2 times 9, for example, right? So 26 and 18 is equal to 40, 46, 46, 40, 40. No, that doesn't work. How about I multiply 13 by 3. So 13 times 3 is equal to 39. And then you have 3 times, that's a 12. 12 and 39 is equal to basically 49 and 51. That's exactly the numbers that we are looking for. So 39 plus 12. 39 plus 12 is equal to basically 2 plus 9 is equal to 11, 1, and that's a 51, right? So that there you get your number. So in case you got confused here, so the way that you can solve this equation is, of course, it's a little bit, the numbers are too large, it's not easy to get the numbers. So what you can do is that, now let me write the numbers over here, 13, 39, and 12, right? So the way that you can write these numbers is that basically, in order to solve this equation, what you need to do is that you need to take the product of this number and this number, meaning that the coefficient of n squared and the constant. So that's 3 times 156. Now, in order to make this simpler for myself, I did prime factorize this number 156 and wrote it as 3 times 2 squared times 13, right? Otherwise, I wouldn't know what sort of number I were dealing with. So that means that basically 156 is this number and 3 is just 3, so I can write it as 3 squared times 2 squared times 13, right? Now, I need to basically, I need to take these factors and somehow multiply them together in such a way that I get two numbers, again, in such a way that the sum of those two numbers becomes negative 51. Negative 51, which is basically the number that I have as the coefficient of the middle term, right? So that means that then I can, for example, write 13. I can take a 13 from here, and of course all of the numbers must be multiplied together. You cannot leave anything out. So you have to write 13 over here and take a 3 from here. So you have two 3's here. Write the 3 over here. And then take the other 3 over here, and then you have two 2's over here. So this becomes 39 times 12. and then I make this a negative number. I make this a negative number, and then 39 plus 12 is equal to 51. So negative 39 plus negative 12 is negative 51, which is exactly the number that I'm looking for, right? Now that I have basically the two numbers, negative 39 and negative 12, I will use them in order to rewrite the coefficient of the middle term over here, which is to say that 3n squared minus 39n minus 12n plus 156 is equal to 0. So in a way, you are basically taking the equation apart in such a way that you can basically take the common factors out. And now, as you can see, from these two terms, for example, from these two terms you can take a 3 out and an n out. So you have n over here minus 4. That is basically negative 12n, right? And from these two terms you can take a so if 156 is basically, you have already a 3 in there, you have already a 13 in there, so 39 already is in there. So you can take the negative 39 out and write it as n minus basically 4, right? Because 39 times 4 is equal to 156. And this becomes positive 156, this becomes negative 39n, which is exactly what I have here. This is equal to 0. And then you can see that n minus 4 is common between this term and this term over here. So I take that out, n minus 4, and write it as basically, from this term what will be left is 3n minus, from this term what will be left is 39, and that is equal to 0, right? And that tells me that either n minus 4 is equal to 0 or basically 3n minus 39 is equal to 0. This means that n is equal to 4. This tells me that basically if I divide by 3 I will get n minus 13 is equal to 0, which means that n is equal to 13. So I think both of these answers are acceptable as long as they work. Meaning that you have to basically actually plug in the values, and to make sure that they actually work, you have to plug in the values and test them. But, well, since the text suggests that basically both of the numbers are acceptable, that means that n is either 4 or 3. In both cases, you can say that basically you can take either 4 terms or 13 terms, and in both cases the sum becomes 78. And, well, you will get two numbers, mainly because basically if you take 4 terms, you're dealing with mainly with positive numbers. So if you take the first 4 numbers, you will have basically 24, you have 21, 18, and your d is equal to negative 3, so you get a 15 over here. Add all of these numbers together, you will get 24, 21, 18, and 15. Adding them together, you will get 5, and so that's basically 10 and 18. 10 and 8 is equal to 18, 1, 3, 5, 6, 7, 8. As you can see, you'll get exactly 78 here. And also, if you go basically 13 terms, logically you should get, logically the sum should grow if you go more into the terms and take more terms, so on and so forth. but because these terms 24, 21, 18, 24, 21, 18, so you can see that your d is equal to negative 3 here, right? Your d is equal to negative 3. That means that you'll get a 15 here, you'll get a 12 here, you'll get a 9 here, you'll get a 6, 3, and 0, and negative 3. You can see that from here, the negative terms begin, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the 10th term. Meaning that from the 10th term, the negative terms begin, and so you're adding a negative number with the terms, and therefore the value of the sum is going to be less and less and less and less, and so again you will end up with the same number, 78. And as a remark, basically here we have in this case the sum of the first 4 terms is equal to the sum of the first 13 terms, meaning that S of 4 is equal to S of 13 in this case. And 2 answers are possible because the sum of the terms from the 5th to the 13th will be 0. This is because A is positive and D is negative, so that some terms will be positive and some terms will be negative and will cancel each other out. And that is basically what I showed you here. So for example, here you would have basically so here you would have, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you would add a negative 3 to this. You'll get negative 6 and negative 9, for example. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and negative 12 here. So 2, 4, 6, 8, 10, 12, 13, right? And so you can see that these terms, and this keeps going, but this is basically 13 terms. And as you can see, negative 12 and 12, you can cancel them out if you were adding them together. Negative 9 and 9, you could cancel them out. You could cancel this out with this one with this one. 0 is 0. And then again, you would essentially be left with 4 terms, which is basically what we got over here, right? So that's basically this example, and these are the kinds of things that need to be understood in this chapter. This is these little things are the heart of this chapter. There is a couple more things left from the exercises, which we will discuss in the next video. Thank you.